This video, we're going to talk about 2.5 Objective 4, where we find slant asymptotes and sketch graphs of rational functions. So let's go ahead and start by doing our long division to find our slant asymptote here. X squared divided by x is x times x is x squared, x times 7 is 7x. Going to subtract. Negative 7x divided by x is negative 7. And add, it's going to be 30. And we're not going to care about that part as x goes to infinity. The slant asymptote is y equals x minus 7. We have a vertical asymptote at x equals negative 7. And we're going to be looking for the graph here. Let's just sketch. Negative 7 is over here. Slant asymptote x minus 7. It's going to go through like this. And we have a y-intercept at negative 5 over 7. X-intercepts at root 5 and negative root 5. So we're going like this up here. And then we should have the other piece over here as we get close to negative 7 from the left. That's a negative, and that's a positive. So this is going to go to negative infinity, and it should not cross that. No, it's not going to cross that slant asymptote. It's going to be like this. And let's see. Bad sketch of it, but it's going to look like C here. That's a better sketch if we use these for our window here. Just gave you a general idea what was going on. 3x minus 4 to x squared minus 4x plus 6. We get 1/3 x here. It's going to give us x squared minus 4/3 x. Change our signs. 12 over 3. So that's a negative 8 over 3. X plus 6 minus 8/9. Plus 32 over 9. Add, subtract. 54 minus 32 is 22 over 9. And this part doesn't matter. It's going to be y equals 1/3 x minus 8 over 9. And the function has a vertical asymptote at x equals 4/3. And we have 4/3, 1/3 x minus 8/9. It's going to be kind of shallow like that. And we have x-intercepts at half of this number squared. We have no x-intercepts. We have a y-intercept at negative 3/2. So that looks like B. Can do that. All right. X squared plus 1 into 3x cubed plus 5x squared plus 5x plus 3. So this is going to be 3x and then this is going to be plus 5. And y equals 3x plus 5. And we have no vertical asymptotes. And we have a horizontal, no, we have an oblique that we just found. So we need to see if it crosses that oblique. Is this ever equal to let's see. Three x cubed, 5x squared. So we get 2x equals 0, x equals 0 is where it should cross. When x equals 0, y is 3, so it should cross at 0, 3. And this is positive leaning asymptote here. That looks too shallow. And this one doesn't approach the asymptote at all, so it can't be that one. It's got to be this one. And it is. All right, is it possible for a rational function to have both slant and horizontal? No, you can only have one y equals. They're both going to be, both ends are going to be finite, or both ends are going to be infinite. So no, you can't have both. So this is A. The function f has a horizontal asymptote when the degree of the numerator is less than or equal to the degree of the denominator, while f has a slant asymptote if the degree of the numerator is exactly one higher than the degree of the denominator, so you can't have both situations. B, is it possible for an algebraic function to have two different slant asymptotes? Explain or give an answer. Yes, an algebraic function can have two different slant asymptotes. For example, when I have f of x equals x to the fourth over the square root of x to the sixth plus 1, then it has two different slant asymptotes, y equals x and y equals negative x, depending whether you're going to positive or negative infinity there. So that's absolutely okay to have that. And analyze limit of f of x as x goes to infinity and limit of f of x as x goes to negative infinity here, and determine whether f has slant asymptotes. So let's go ahead and expand this. So we're going to have a horizontal asymptote here at 2/9 on both sides. And the function does not have a slant asymptote, it has a horizontal asymptote. Y equals 1 is the horizontal asymptote. Vertical asymptotes 2x, x, -5, and +1. That gives me x equals -1/2 and x equals 5. Right, and then there are no slant asymptotes because they had a horizontal asymptote. And this function is find all asymptotes. So this is the same thing as x plus 2 plus 3/x when x is greater than 0. And this is the same thing as -x minus 2 minus 3/x when x is less than 0. So let's go ahead and look at, it's going to have two different slant asymptotes here. Has no horizontal asymptote. It has a vertical asymptote, one of them at, the function has two slant asymptotes. When it's less than 0 is y equals -x minus 2. And when it's greater than 0, y equals x plus 2. Function has a vertical asymptote at x equals 0. So we're looking at A here. And that's it. We'll come back next time and talk about 2.5 Objective 5. See you for the next video.